Today is August 24th, 2026. This research overview is AI-generated, based on a partial daily collection, and requires human review. 22 supplied paper analyses are represented, but several source routes failed and some surveys were heavily truncated. The clearest theme is that artificial intelligence research is shifting from raw capability toward controlled, efficient, and inspectable systems. We will focus on measured results, separate them from author claims and editorial connections, and close with the questions that still need stronger experiments.
Start with efficiency. Paratempo dynamically prunes, retires, or forks parallel reasoning branches. On 4 reported benchmarks with one Quen model, it averaged 71.1% accuracy, compared with 72.2% for 16-branch self-consistency, while cutting latency by 21.8% and generated tokens by 30.3%. That is a measured trade-off, not free acceleration. Tests covered only 2 models, mostly mathematics, discrete answer formats, and one A100 GPU. A crucial open question is whether its confidence signal identifies correct reasoning or merely stable, confidently wrong answers.
Efficiency also appears at training scale and on constrained hardware. A mixture of experts study fitted learning rate behavior on proxy runs and predicted a workable rate for a much larger 10 trillion token run. Near 500 billion proxy tokens held out predictions differed from estimated optima by about 4.4% on average. The full run remained stable, but no neighboring rate was trained at target scale, so the claim of optimality remains untested. The obvious next experiment is prospective validation around 1 to 2 trillion tokens, using the predicted rate and close alternatives.
For inference, sparse PR executed roughly 22 to 26% of video attention pairs across 4 models and reported end-to-end speedups from 1.48 to 2.61 times, with quality close to dense attention. Daedalus, a CPU-oriented convolution attention hybrid, decoded 1.76 times faster than its parameter-matched dense counterpart at a 2048 token context, with effectively tied downstream quality. Llama Mobile compressed one vision language model to 2.68 bits per parameter and reached 3.8 decoding tokens per second on a Pixel 8a, but its average evaluation score fell from 0.744 to 0.661.
Those results describe 3 distinct engineering levers: sparse computation, architecture, and numerical representation. Their shared category does not prove that the methods combined cleanly. Measurements also came from favored configurations. Sparse PR used one H100. Daedalus had 1 training seed and excluded prompt processing from timing, and the mobile result excluded loading and prefill. A meaningful follow-up would repeat every comparison across hardware, seeds, context lengths, and full interaction latency, including vision encoding and energy. Until then, these are promising operating points rather than universal deployment rankings.
Multimodal evaluation is also moving beyond answer correctness. OmniAssist Bench tests timing, continuity, visual prompting, and appropriate silence in assistant-like audio-video interactions. Its best-tested model scored 66.4 out of 100, while the strongest-tested open model scored 51.2. Pattern eval instead measures visible response failures, such as leaked deliberation, repetition, contradiction, and unsupported displays of reasoning. Across all 25 matched configurations, non-thinking mode triggered more failures. Pattern-aware reinforcement learning reduced trigger rates by about 13 to 14 points on 2 model sizes, though the smaller model lost more general task accuracy.
The evidence is useful, but conditional. OmniAssist Bench follows fixed offline paths, uses an automated judge, and applies model-dependent video pre-processing. Pattern eval deliberately enriches for failures, so its rates are not estimates of ordinary user traffic. Its contradiction and performative reasoning labels are also less reliable. Editorially, the 2 benchmarks look complementary because one tests when and how an assistant participates, while the other tests the shape of its delivered response. That is a supported shared problem, not evidence that either group influenced the other. Both now need blinded human validation on natural interactions.
Post-training presents a related interference problem. One distillation study found that teacher behavior can transfer beyond the supervised prompt domain, including weaknesses, and that mixtures of teachers can pull several capabilities in unexpected directions. Shared model lineage was associated with broader transfer, but it was not causally isolated. Clear takes a different approach by continuously gating a safety adapter from hidden states. On one 8 billion parameter model, harmful response success fell from 32.25% to 0.50%, while math accuracy remained 73.46%. Yet over-refusal increased and broad knowledge performance declined.
So capability preservation should be measured as a vector, not a single score. Safety gains, useful answer retention, over-refusal, knowledge, and off-domain transfer can move differently. A strong next study would match teacher and student pairs by initial policy distance rather than lineage, then compare routing and gradient conflict controls under identical budgets. Clear also needs multi-turn and multimodal tests. The measured numbers support conditional safety improvement in one setting. They do not establish a general solution to alignment interference.
Another cluster replaces isolated prompts with persistent executable worlds. Agent Mercury generated synthetic business environments with deterministic validators. Fine-tuning its world author raised success on all 12 validators from 3.3 to 83.3% across 30 held-out briefs. Training agents in those worlds also improved the reported enterprise average, though one domain regressed. Recverse simulated long shopping sessions. Its F1 rose from 4.27 to 7.19%, and people preferred it over a baseline in 92% of comparisons. But real shopping trajectories were still preferred over Recverse 74% of the time.
Execution scoring can improve auditability without guaranteeing realism. FlavorBench exhaustively grades culinary portfolios against a program called Epicure. Its highest point estimate was 65.1, but only 101 of 351 pairwise comparisons remained resolved after correction, so the leaderboard was not fully ordered. Likewise, Agent Mercury's worlds are synthetic, and Recverse still trails real behavior. The central open test is matched comparison. Hold models, tasks, optimizers, verifiers, and interaction budgets constant. Then compare scenario-built worlds, task-centric generators, and real or sandboxed traces.
Finally, visual and embodied systems are making control explicit. Infinity Edit reported a camera motion score of 0.7654 versus 0.5494 for the next highest listed method, but its supposedly unbounded behavior rests mainly on one qualitative demonstration beyond 1,000 frames. Hydra Zero's generated and reference policy outcomes correlated at 0.96 over 300 open-loop episodes, which does not validate closed-loop reactions. PhysCap actively measured hidden physical properties and achieved 78% success on 50 simulated empty cup trials. Together, they suggest complementary work on predicting visible consequences and acquiring hidden state, not a proven combined system.
The concise takeaway is this. Today's strongest evidence concerns narrower efficiency gains, better behavioral diagnostics, and more verifiable environments, while broad claims about unlimited control, real-world fidelity, and general deployment remain ahead of the data. Surveys on graph engineering, human-centric models, and computational Hadith research contribute organizing frameworks rather than new causal performance evidence, and their incomplete source coverage warrants extra caution. For exact methods, measurements, caveats, and the evidence-screened relationship map, follow the linked daily summary. Human review remains essential.